All right, let's talk about the secret language of the universe. And no, it's not math, it's not chemistry, it's force. It's this invisible push and pull that, well, it writes the story of literally everything that moves. So let's dive right in.
Seriously, just think about it for a second. What invisible string is holding the moon up there? And what's that unseen hand kind of pressing you into your chair right now? The answer, of course, is force. And trust me, by the end of this, you're going to start seeing it everywhere.
Okay, so let's start at square one, the absolute basics. What is a force, really? I know it sounds super technical, maybe a little intimidating, but at its heart, it's actually beautifully simple.
Now, this definition, it's way more powerful than it looks. See, a force doesn't just start motion. It can slow things down too, like friction on a rolling ball. Or it can change direction. Think about a bat hitting a baseball. It's also something called a vector, which is just a fancy way of saying it has two parts, a size, which we measure in newtons, and a very specific direction. I mean, you can't just push, right? You have to push somewhere.
So, to really get a handle on force, we've got to know the rules of the game. And luckily for us, a guy named Isaac Newton basically wrote the rule book, like over 300 years ago. These three laws, they are the absolute foundation for how pretty much all motion works.
Okay, law number one. I like to call this the law of cosmic laziness, or inertia. Basically, an object is perfectly happy doing whatever it's already doing. If it's sitting still, it wants to stay still. If it's cruising along, it wants to keep cruising. You know this feeling. Think about being on a bus. When the driver suddenly slams on the brakes, what happens? Your body lurches forward, right? It wants to keep moving. That resistance to change, that's inertia in action. An outside force, in this case the bus brakes, had to step in to mess with the motion. All right, law number two. This one gives us that famous formula, F equals ma. It basically just connects force, mass, and acceleration. And it's super intuitive, really. It's the reason you can get a bicycle moving with just a little push. But try doing that with a car. You'd need a huge amount of force to get that car accelerating at the same speed. It's simple. More mass means more resistance to change, so you need more oomph, more force.
And that brings us to the third and final law. I call this one the buddy system. The big idea here is that forces never act alone. They always come in pairs. So when one object pushes on another, that second object pushes back with the exact same strength. Let's look at a couple of really cool examples to see what that means.
Okay, so this really makes it crystal clear. Take a rocket. A common misconception is that it pushes against the air to go up. But nope, it pushes hot gas down. That's the action. And in reaction, the gas pushes the rocket up. It's the exact same reason you can walk. You push the ground backward with your foot. That's your action. And what happens? The ground pushes you forward. That's the reaction. And that's what's actually moving you.
All right, so we've got the rules of the game down. Now let's meet the players. It turns out we can sort pretty much every force in the universe into two big families. It's a really simple distinction, but it helps organize, everything. And really, it's as straightforward as it sounds. You've got one kind of force that needs to physically touch something to have an effect, and then you have another kind that can influence things from a distance, like from across a room or even from across the entire solar system. Touch and no touch. Simple.
So contact forces. These are the ones we know and feel every single day. When you push a shopping cart, that's your muscular force making direct contact. And friction? That's another big one. It's that invisible drag that always fights against motion. It's the whole reason a ball you roll across the floor will eventually slow down and stop.
And then you've got the mysterious ones. The forces that act at a distance, almost like magic. Magnetism is the classic example, right? You can feel that pull without the magnets even touching. And of course, the big one, gravity. This is the force that answers that question from the very beginning. It's that non-contact gravitational pull from the Earth that's keeping you and me and everything else firmly planted on the ground.
Okay, so we've got moving in a straight line covered. But what about making things turn or rotate? Well, that requires a special kind of twist on force, if you will.
This turning effect has a name. It's called torque, or the moment of a force. And I promise you, you use this concept every single day, probably without even thinking about it. Every time you open a door by pushing on the handle, not the hinge, or use a wrench to tighten a bolt, what you're really doing is creating torque.
And making something turn, it really just comes down to a simple three-step recipe. First, you need a pivot point. Think of a nut or a door hinge.
Second, you need a lever, like your spanner or the door itself. And third, you apply a force, a push or a pull. That combination of the force you apply and how far away you apply it from the pivot, that's what creates the turn. It's the perfect recipe for rotation.
So here's the big takeaway from all this. This isn't just some dry textbook theory, not at all. Once you really get these basic rules, you'll start to see the hidden mechanics, the invisible machinery, behind absolutely everything around you.
I mean, just look at this. From the simple act of walking, that's action, reaction, and friction right there, to how every car, train, and plane moves. From simple machines like levers to massive engineering projects like bridges that have to balance these incredible forces. Even swimming, and yes, rocket propulsion. It's all governed by the exact same handful of principles. Force is, quite literally, the engine of our world.
So I'm going to leave you with a little challenge. The next time you open a door or just take a walk outside or even just watch a leaf fall from a tree, just pause for a second. Try to spot the invisible pushes and pulls that are making it all happen. Because now that you can speak the language of motion, you might find the world looks a whole lot different.